for the last time. When you come after me, don't knock the door, don't say salam, don't say anything. Just enter the room. Silent. Okay? If you have something with your friend, with your mobile, you can go outside, do whatever you want to do, and then return back. But don't use your mobile here in the lecture, and don't speak with your friend. Okay? You have a question, you can ask me, you can speak with me. But if you have some subject with your friend, go outside and finish your subject. Okay, so our last lecture, we mentioned some issues about pattern recognition, what is pattern recognition, and what is learning in the machine. How many types of learning we mentioned last time? For the machine, 3. Who can mention the 3 types? Yes. You don't know it? Yes, you can read. Supervised, unsupervised learning, and reinforcement learning. Okay, so let's continue today for our introduction, give some information about feature formation and feature selection before it. So in machine learning or in pattern recognition, we have 3 types of learning or ways of learning that we can work with a machine: supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, supervised, like our lecture, I give you the information, I discuss with you, I give you the information. After that, I give you exam and ask you about the information. Same issue here. In supervised learning, we teach the computer. There is a teacher provide the information about the patterns, okay, by making categories, and this categories and items will be labeled that it's belong to specific category. So this we name it a training set. Part from the data, we name it a training set. So in supervised learning, all the supervised learning algorithms work like this. You have to give training set for the machine. What is the training set? We have items, data that it's already labeled. For example, okay, we need to create a model that have some classifiers. For example, one classifier, K and N, for example. So how it works? To classify, for example, a cancer disease, okay, from MR pictures. What we will do, we will give some MR pictures that have label. This label make, for example, 2 categories. This category of pictures, okay, labeled as infected, okay, or positive, and the other group as negative or uninfected. Of course, we should have this labeled. Depend on what? What's the features that make this group labeled as infected? What's the features, the properties in this picture that make us labeled as negative or uninfected? Okay, then After that, we can give new data, new MR pictures or photos for the machine, and it will classify it. Depend on what we trained this machine. This machine means the algorithm. Okay, we trained it, or the model, we trained it with some data that it's already labeled. Unsupervised learning here, we don't have a training set. We create the model. When we speak model, about model, the model is actually, when we speak about machine learning or pattern recognition model, it could have one algorithm for classification or for clustering. It could have more than one algorithm. Okay, we will mention many of these algorithms, by the way. It could have many other tools like pre-processing, tools for image, okay, cut the image, duplicate the images, make the images more clear, and so on. Or also, it could have some ways to select the features from the images, and so on. So this is the meaning of model when I speak about model here in machine learning or pattern recognition. So here, unsupervised learning, we don't teach the system. We don't give the system labeled data, but we have to select what features, what criteria that will be used by this machine or by this algorithm to cluster the data. What's the meaning of clustering the data? Make the data as different groups. Okay, so we did not teach it before, but the system will look to the data, for example, pictures or text, and try to group items that have same features into one group. Okay, we have many questions here. For example, how many groups we could have? Okay, for example, we have a website, okay, and we selling some items in this website, and we want to cluster, group the countries depend on the sale amount. If it's high, low, medium, okay. How many groups we could have here? We could have two groups, for example, high, low. We could have high, moderate, low. We could have, okay, 5 different groups. Okay, very high, medium, or moderate, and low, and very low. It's depend on what we select for the algorithm, or in some cases, there's, for example, k-means. K value here in the algorithm, K means it's a clustering algorithm. K means how many clusters the algorithm, how many group. Cluster means group. This algorithm will organize the data into, or the items into clusters, into group. K, the number of groups. We have some ways to select this K. Okay. Maybe we can make it manually, or we can program it with specific criteria to select the number of K. When we reach some of this clustering algorithm, we will see how many groups, how many clusters, and how to select number of clusters that necessary. Okay, what another issue? Okay, so number of clusters, this one issue. The other issue, what's the features that will be used to cluster, to group. Okay, we will give examples now about some data to see it. Reinforcement learning, again, it's like teaching the kids. Okay, so how you teach the kids? I was about saying your kids, but I think most of you don't have kids. Yes, maybe all of you or most of you, I don't know. I had some students that have kids, okay, in some classes, but generally you don't have. Okay, like kids, if I want to teach my kids something, the kids usually do something, then you will say for them, okay, this right or this wrong, don't do this again because it's not right, it's wrong. Same issue here. Reinforcement algorithm, this algorithm um, depend on feedback from the teacher, that when the machine doing something, that the thing correct or not correct, right or wrong. It's have many applications, for example, if we will create a smart robot. In some cases, this smart robot don't have information in some situation, but this robot have to learn by what? By reinforcement learning. When doing something, this thing, we will give feedback. Is it right or wrong? Next time, it will not do the wrong issues. In gaming also, to make the computer do the gaming, and we need the computer to learn. Okay, in some situation, we don't have data about issue to train it. But when it's in that situation, and for example, do something wrong in the game and get feedback from the game that it's you game over, you failed, not correct, then the algorithm or the machine try to learn by this feedback. Okay, here example for supervised learning. So we have two steps, two major steps in supervised learning. First issue, teach the machine, learn the machine, give the machine training set that it's already labeled. For example, here we have two different features here. First one is the share. So we have data, and we organize this data into two categories, and we give the machine that this category is triangle, and this class is circle. So any shape with three faces is triangle, with zero face or side, I mean, with zero side, it will be a circle. Okay, so we give this from the training set to the machine. Now, the machine, when we give any new data, if this shape have three sides, then it will be classified into triangle. If it have four sides, it will be classified as rectangle, for example. If it's have zero side, it will be classified as circle. Okay, we could have more features. For example, color. So imagine we have two colors, blue and yellow here. So we give labeled data. This data or items, it's blue. This, it's yellow. Of course, the machine can read the color, okay? Because all the data actually in the machine will be stored as numbers, as data, yes, at the end. But if you speak about picture or something visual, it will be about lightness. Most computer or machine now can read the colors by the lightness of the color, okay? Each color have different curve for the lightning, okay? So after that, we give items. So first step, we train. Second step, we could give any new objects for the machine and the machine will classify. So second step in the supervised learning is the classification. So according to our training set, okay, this have 3 sides, so it will be classified as a triangle and its color yellow, so it will be classified as yellow. So the machine will tell you at the end that this is a yellow triangle. We could have more features, for example, size. So if we have size, we could have another label that we have small size items and large size items. Okay, so depend on it, this triangle could be classified also, for example, as large. So we have 2 groups, 2 classes here, small and large. So, okay, it's large. So this yellow, large triangle, and so on. In the unsupervised learning, we don't give previous data. We don't train the model. We give unlabeled training set, and depend on some features, it will classify it into 2 groups, cluster it into 2 groups, 3 groups, 4 groups. We have to identify how many a group could be clustered. And all this will be in another category. So we did not train the machine before that, but depend on some criteria, some feature, similarity in the feature, it will organize it. By the way, it's not difficult. It's easy issue. Even you will do the classification, not the machine, of using some algorithms. This is our job here. Hello. You attend last year in the same course, yes? You? Because you usually don't attend lectures. But we have attendance system now, so you have to attend. Right. He taught with me maybe most, I think, 4, 5 courses, the most between your friend. You take courses with me, but you never attend. You never attend. So today you attend because we have attendance system, yes? Okay, I think after 10 minutes we can take a break. Okay, not now. Let's continue. So we have many ways to cluster it. Depend on the size, small size, big size, depend on the color, yellow, blue, and so on. different color. It will organize it depend on some features. We will see examples for k-means algorithm doing this clustering. Also, we'll take an algorithm as a classification, so you will know the difference between. But at the end, okay, how it's working this actually all these features at the end will be as numbers in the computer. And these numbers will be as vector, okay, graphic object, okay. For example, we have object X. One feature, for example, the size. The size could be large, small, and so on. We will not take the size, okay, it's 100 centimeter, 99, and so on. To make categories, we will categorize for classification three different categories. So we have large, medium, and small. So large, for example, once this item large, so it will be 3, the data. If it's medium, 2, and so on. We could have more features. We could have, for example, 2 features and the color. Okay, if we have, for example, the size and the color for item X, so we have 2 features. So the vector will have 2 types of data, the size and the color. For example, it's medium, so first item in the vector, which is the size, will be 2, for example, if we have 3, 2, 1, the size. About color, if we have 2 colors, for example, like here, blue and yellow, so we could give blue 2 and yellow 1. So if this one yellow, then the color is 1. So at the end, you will convert everything, even if it's image, you will extract the features and convert it into vector that have some numbers that represent the features. So if it's vector and have numbers, so we can imagine it as what? I will come here, then I will return. So we can imagine it in the coordination system. Okay, as a human, we can imagine until how many features? 3, because until 3 dimensions, and as a human, we cannot imagine, yes? We can imagine 2 coordination system, 2-dimension, 3-dimension coordination system, but 4-dimension, we cannot imagine. But the machine can calculate 100-dimension, 1,000-dimension, doesn't matter, okay? But it matters about the efficiency here, the calculation time, and so on. So you can imagine it as points in the coordination system. Okay, if it's points in the coordination system, how to classify it? Usually the points that close together, it's from same class. So, and the features that far from each other, it's from different class. So, how to know if these points close together or far from each other? By calculating what? The distance. So in our course, you have to understand how to use the vectors or points, point in two coordination system, in 2D coordination system, it's contain X, Y only. But in the 3, it's have X, Y, Z. If more than 3 could have more than, but at the end it's point, and you should know how to calculate the distance between the point to know if these points will belong to the same class or same class or no. All or most of the clustering and the classification algorithm depend on this. Convert data into vectors, then vectors means points that represent or represented by vectors, okay? Then find the distance between these items or between these points. So each item will be represented as point or vector data at the end. Okay. So most models in the pattern recognition or pattern recognition process have these steps. And these steps, you can have some algorithms in each steps to do this job, depend on type of data. For example, sensing. Sensing means get the data, collect the data acquisition, okay, about the items that you need to classify or cluster. For example, we could get the data by camera. So the sensing here, take video or pictures by camera. For example, we could have camera here for face recognition to know the students' faces and attendance, okay, and connect it with the attendance system. It could be a nice senior project, okay? If some of you want to do it with me, it's okay. I will accept it. It's a nice project and we can use it next year with the students. So no one can make attendance for his friend. Okay, so this sensing could be mic, for example. Could be mic to get sound waves. For example, we have mic on the door, and only the students can attend the lecture. So, hello, I'm Ahmed. The voice will be taken by the mic, so it's sensing. Then it will be recognized by the system, and okay, Ahmed, you can enter and take the attendance. Also, it's another way to take the attendance, because university now it's focusing too much about the attendance of the students. Okay, so this is sensing. Then segmentation. What is the segmentation? When you collect data using the sensors like camera, like mic, and so on, you get many noises, you get many unneeded data. So segmentation here to remove the noises data to get only the items or the data that you need. For example, the camera could take many objects. We need only the face, so we segment the face. Okay. For example, MR image. You know the MR device, magnetic radio device that it's like a circle like this, and the patient will go inside it. I used it 2 times in in the summer holiday. Okay, first time it was not clear. After 2 weeks, you have to repeat it. Then they have to inject some medicine to make the scan more clear. So, what this scan will give? Some pictures from the human body. For example, we need to check the cancer in some places. For example, in the brain. Some art will take the image for the whole brain, but you need the areas that have some infection. So the algorithm here will segment only this area, will take only this area to examine this area. We don't need many information that are needed. So this is a segmentation. We remove the background, the noise, and so on from the data. We name it usually pre-processing because we could have many steps here, not only segmentation. We could have also some algorithms to clear the photos. If the data set it's not enough, we could have some algorithms to increase the data set. How to increase the data set? Any ideas here? You have number of pictures, for example, and you want to increase the data set. Yes, if you have 100 images, if you flip the images, you will get 200 images. The direct image and the flipped image. Okay. It's important. Why? Because we could have the item in the picture in this side, another time in another side, and it reflects the real way. Okay. We could change the color and so on. We have many ways to increase it. Also from pre-processing. For something called, what's the feature extraction? Here, take the data about from the sensing from the sound, from the text. This data could be waves, could be the lightness of the image, could be the size of the image. All this feature, we extract this feature. When we extract the feature, it will be converted as numbers at the end in the vector. I show you the feature vector. At the end, all this feature will be inside the feature vector. So if we have element X, we will have, for example, 3 features. So the feature vector of X will have 3 different data. For each feature, we have data about this item. Then we have the classification. Classification here, if we speak about supervised learning, then we have 2 things in the classification. Train the model. How to train the model? Give label data for the algorithm. So we train it by give label data. It's not difficult. If you learn machine learning, maybe you can understand what I'm speaking about. You will understand it when we take some algorithms. It's not difficult. It's easy issue. Even you will do the training for the algorithm, and you will calculate some data in the algorithm. Then later, you will know how to classify new items. So we have 2 parts here in the classification. Train the algorithm by labeled data. Second step, classify. By the way, the training, we do it, for example, 1 time or 2 times if we need to increase the accuracy, but it should not be many times. Okay. Then after that, we can use the algorithm many times. Not every time you need to train it. You train it, now it's a train, like we train you here. You don't need to come again to university every time you want to go for a job. Yes, we train you one time and you go to job and you find that you need to train yourself again. Of course, university gives you only the basics. If you did not upgrade yourself, enhance yourself, you will not be able to work. We don't prepare you here for the workplace directly. You should do efforts. Okay? You have to know this fact. So after that, we have post-processing. Post-processing, here we evaluate. We can take one break because we already passed the break time. So we can take, after finish this slide, we can take one long break, for example, 15 minutes instead of 10 minutes. Post-processing, we have to evaluate if the classification done correctly, if we have something wrong. For example, if the algorithm or the model have overfitting, what's the overfitting? There is difference between the work of the algorithm when we train it and in the real use when we test it. Why? Because some people make too many training for the model, for the algorithm, train it too many times. What will happen? The algorithm will be only for this training set. So it's like you overfit it. You give it too many information about the training set. So any items that you will test it or classify it, that it's not very, very close for the training set will be classified in wrong way. Okay? So this is the idea. If you train your model too much, then it's like you create your algorithm or model only for the training data. Any other data or items will not be classified correctly. Okay, so there should be some balance. Why some people train the algorithm too much? To make some fake their model. Okay, I train my model. Okay, you have, of course, the training and testing set from the same data set. So same type of data. So you train your model too much about this data. When you test it about same data, for example, you make 80% for the training set, 20% the remain. For the testing, you will get accuracy almost 100. Oh, my model, my algorithm, very good. But if we use different data set, we will get, for example, 30% accuracy or 40%. Why? Because you make your algorithm or model only for this data set. You train it too much about this data set. So any other noise or the unneeded data in other data set will affect the decision here. Why? Because the data could have some noise, some relevant data. When you train it, it's start to take even the noise and irrelevant data. So you have something called overfitting. It's take many data about the data set that it's not needed for the classification. Okay, so this is the post processing to evaluate if, so we have some measurement here, okay? Some matrices like overfitting tests, like confusion matrix, and so on, to test if let me take the attendance, but let me stop this recording.